Another step 2 question then. This is 2009, step 2, question number 4. It's also question 4 from the Miscellaneous Pure step 2 module. It's a really lovely, quick question. P of x is a polynomial of degree 9, so its highest power is degree 9. So this is an example of it. P of x minus 1 is divisible by this. That means that you can write P of x minus 1 as this thing times some quartic. Because if this is degree 9, taking away 1 doesn't change that. So this whole thing is degree 9, which means this must be a quartic is degree 4. So degree 4 times degree 5 will make degree 9. So it's this kind of idea. Find the value of P of 1. So let's just put 1 in there. Because what you'll notice is you get P of 1 minus 1 equals 0 times something. But 0 times something is 0. So therefore P of 1 is 1. So that's nice and straightforward. Show P dashed of x is exactly divisible by this. So we're just going to differentiate this. This will involve some product rule. I can do this without knowing what this quartic is. And you'll see why. Because all I need to do is differentiate. I mean, this is product rule, right? You differentiate one, leave the other, differentiate the other, leave the other alone. So differentiate this for 5x to the minus 1 to the power 4. Leave this alone. Differentiate this, which will just give you some cubic. I'm not going to care what it is, and leave this alone. And now we can factorize out x minus 1 to the power 4. And yes, now P dash of x is divisible because it's this times something else. That's what divisible means, in case I didn't make that clear. So therefore P dash of x is divisible by x minus 4 to the power, x minus 1 to the power 4. Given also P of x plus 1 is divisible by this. So let's set that up. Because again, it's a quartic because we're still going to get a power of 9 over here. Now, P of x plus 1. Now, x plus 1 here. If we want to do the same trick as before, and STEP is all about trying to replicate tricks that you've done before in each question, we're going to need to use x as minus 1, because that's going to make this go away. So if x is minus 1, you get P of minus 1 plus 1 equals 0, and so P of minus 1 is minus 1. So that seems useful. They didn't ask me to do that, but it seems useful, and it's trying to repeat the process that they've done as you go along. That's what step questions are all about. So we have that result down as well. And now what else can we do? Well, let's just differentiate, because that's what they asked us to do last time. So let's just do that again. Let's differentiate. We get P dash of x, 1 differentiates away, obviously, equals this. We can factorize out an x plus 1 to the 4, and we can argue that P dash of x is now divisible by x plus 1 to the 4. Now, a few things to say here. P dash of x is divisible by x minus 1 to the 4 and x plus 1 to the 4. Now, P of x is degree 9, which means P dash of x is degree 8. And if it's divisible by both this thing and this thing, there literally can't be anything else in P dash of x aside from those two things. So therefore, P dash of x is just this, with some value of k here. Don't forget, that value of k is super important because that doesn't change the degree, but it does change, the coefficient of x, the 8. So you do need a constant there, and that's going to be important for the last bit. But we have P dash of x as this. Okay, so find P of x. Well, we have P dash of x. So finding P of x, how hard can it be? What we could do is we could integrate this, and that would give us something in terms of k and a plus c at the end. That's 2 unknowns. But the great news is, because they asked us to, and because of our intuition and our ingenuity, we have 2 boundary conditions. 2 unknowns, 2 boundary conditions. That sounds pretty good. So we're going to integrate this side. Now, I can't really integrate this very easily, so I'm going to just expand it out like a complete muppet. I'm going to be a bit smarter. I can say that this is x minus 1 times x plus 1 all to the 4, and then expand out, because then I only need to do 1 binomial. If you're doing it that way. So I can do this, and then I can just write it like this. I can integrate both sides here because it's super easy to integrate now, and you end up with this. You can maybe times the k through all of these if you want to, or don't. It's up to you. But that will be P of x. And now we can just shove in P of 1 is 1. So we can say all of this with a 1 in it is equal to 1. And all of this with a minus 1 in it is equal to minus 1. Now, the nice thing is that when you simplify these, it's not too difficult to do considering it's just ones. When you sort of half simplify it, you just notice this and this are exactly the opposite of each other. And of course they are, because the minus 1 is changing the minuses to plus and the pluses to minus. So this stuff is exactly the same as this, which is super nice because it means you could add these simultaneous equations together and just end up with 1 plus minus 1, which is 0, equals 2c. So therefore c is 0. And then we go back up to the top, but we remove the c because we know it's 0. And we just need to put in one more condition here to make this work. So I put in the 1 condition just because it's easier. And we'll try and sort this out. It's pretty boring and pretty annoying. But if you just gradually make all of the denominators the same, and I know it's as bad as it sounds, but eventually it sort of works when you do it. It's annoying. There's no way around it. It's annoying. But anyway, that all equals 1 based on the initial condition. So therefore, K is times squared size by 315 divided by 128, 315 over 128, which means P of X is just that with that in it there. And that's the whole question done. Thank you for watching.